Understanding sklearn. Isotonic. sklearn. Isotonic is a module within the scikit-learn library dedicated to isotonic regression. A technique for fitting a monotonic non-decreasing or non-increasing function to data. It is particularly useful for situations where we expect the relationship between two variables to follow a specific trend, even if the raw data doesn't perfectly reflect that trend. Key concepts. Monotonicity. A function is monotonic if it either consistently increases or consistently decreases as its input increases. Regression. This refers to the task of predicting a continuous target variable, often denoted as y, based on one or more predictor variables, often denoted as x. Isotonic regression. A type of regression that specifically constrains the fitted function to be monotonic. It's like finding the smoothest monotonic function that best fits the data. Why use isotonic regression? Enforce domain expertise when prior knowledge suggests a monotonic relationship. Isotonic regression ensures the model reflects that knowledge, preventing unrealistic fluctuations. Handle noisy data. Isotonic regression can effectively handle data points that deviate from the expected monotonic trend, finding the most plausible monotonic fit. Interpretability. Monotonic functions are easier to interpret than more complex models. Key function sklearn. Isotonic. Isotonic regression. This is the primary class used for isotonic regression in scikit-learn. Let's delve into its key attributes and parameters. YAML example with explanations. YAML. Isotonic regression. Input data for the predictor variable x. x1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Input data for the target variable y. y1, 3, 2, 5, 4, 6, 7, 9, 8, 10. Determines whether to enforce increasing or decreasing monotonicity. Default is increasing. Increasing true. Specifies the method used for solving the optimization problem. Linear is the default and often preferred for its efficiency. Quadratic can offer greater accuracy in some cases, but may be slower. Method linear. Controls the level of smoothness in the fitted function. Larger values encourage smoother fits. Smaller values prioritize fitting the data more closely. Default is 0.0. Smoothness 0.0 allows for specifying a prior over the output values. This can be useful for incorporating prior knowledge about the expected range of the target variable. Default is none. Ymin none allows for specifying a prior over the output values. This can be useful for incorporating prior knowledge about the expected range of the target variable. Default is none. Ymax none specifies the interpolation method used for predictions. Default is linear. Other options include nearest, 0, etc. Refer to the documentation for details on each option. Interp method linear. Explanation of key values. X represents the input predictor variable. It should be a 1D array or a 2D array where each row corresponds to an observation. Y represents the target variable. It should be a 1D array of the same length as X. Increasing a Boolean value specifying the desired monotonicity. If true, the fitted function will be non-decreasing. If false, it will be non-increasing. Method specifies the optimization algorithm used. Linear is the default and typically efficient. Quadratic might offer better accuracy but can be slower. Smoothness, a float value controlling the level of smoothness in the fitted function. A higher value encourages smoother fits. A lower value prioritizes closer fit to the data. Ymin, a float value specifying the minimum value the fitted function can take. Y max, a float value specifying the maximum value the fitted function can take. Interp method specifies the interpolation method for predictions. Linear is the default and uses linear interpolation between known points. Other options like nearest or zero might be appropriate depending on the desired behavior. Example usage. Python. From sklearn, isotonic import isotonic regression. Sample data. x1, 2, 3, 4, 5, 6, 7, 8, 9, 10. y1, 3, 2, 5, 4, 6, 7, 9, 8, 10. Create an isotonic regression object. IR isotonic regression. Fit the model to the data. IR. Fit X, Y. Make predictions on new data. New X 1.5, 3.5, 6.5. Predictions IR. Predict new. Print the predictions. Print predictions. This code demonstrates how to use isotonic regression to fit a monotonic function to sample data. Make predictions on new data points. And retrieve the fitted values. In conclusion, sklearn, isotonic provides a powerful tool for handling situations where a monotonic relationship between variables is expected. It allows for incorporating prior knowledge, managing noisy data, and maintaining interpretability. By carefully selecting the parameters and understanding the underlying concepts, you can effectively leverage isotonic regression in various machine learning applications.